Today's topic is matter and change. We're going to discuss properties of matter and changes in matter. And if at any time you need more time to write down your notes, just pause the video while you write. Let's get started. In this lesson, we're going to make a couple of tables so we can compare and contrast concepts side by side. The first two we're going to look at is extensive properties versus intensive properties. So let's divide our paper. An extensive property is a property that changes when the amount or the size of the sample changes. So think about properties that are different if you have a large sample versus a small sample of that substance. Things that would be different would be mass. We can see here if you have more apples, they're going to weigh more than if you have a smaller sample of apples. Another example of an extensive property could be volume. A large amount of water is going to have a bigger volume than a smaller amount of water. Mass and volume depend on the size of the sample. By contrast, an intensive property is a property that stays the same no matter the size of the sample. So these are going to be properties that when you change the size, there's no change in these properties at all. An example would be the melting point. Water is going to melt at 0 degrees Celsius, whether you have a large piece of ice or a small piece of ice. Water is also going to boil at 100 degrees Celsius at normal atmospheric pressure. So the boiling point is also the same regardless of the amount of water that's in the pot. Another example would be density. The density of water at room temperature is 1 gram per milliliter, and it doesn't matter if you have 5 milliliters of water or you have a gallon of water. Its density is going to be 1. Another example could be the color. When you have a smaller sample of copper, it still has that same brown metallic color as a larger sample. One memory device that might work for you is that extensive properties depend on X amount, and when the amount of X changes, that property is going to change. Whereas an intensive property is in common or the same for all sample sizes. The next two things we're going to compare would be a physical property versus a chemical property. And again, we're going to make that side-by-side comparison chart. A physical property is a property that you can observe without changing it into a different substance. Examples could be the melting point or the boiling point. You can measure the temperature at which something melts or the temperature at which it boils without having to have it undergo a chemical reaction and change into a different substance. Color you can observe without changing it into a different substance. Same with density. And there are two important vocabulary words that we're going to include here. The first one is malleable. Malleable means that it's bendable, or if you hit it with a hammer, it's going to flatten out into thin sheets as opposed to crumbling and breaking when you hit it. A perfect example is aluminum foil. It's a very thin layer of aluminum metal. Most metals are malleable. It's a very important feature of metals. The other word is ductile. And ductile means that you can draw it into a thin wire. And again, that's another property of metals. Metals tend to be ductile. We use copper in our electrical wiring because it can easily be drawn into a thin wire, and it's a great conductor of electricity. In observing whether something is malleable or ductile, again, you're not changing it into a different substance. You're just seeing if you can draw it into a wire. If you hit it with a hammer, does it flatten or does it break? Now, a chemical property, on the other hand, is something that describes how a substance is going to react or how a substance is going to behave in the presence of something else. Some examples could be saying something is flammable. That means that in the presence of oxygen, it's going to be able to catch on fire. You're explaining how it behaves around oxygen. Or maybe something is explosive. We know then that it's going to react to release a tremendous amount of heat and energy in a very short period of time. It's describing behavior. You could say something is corrosive. That would also be a chemical property because corrosive means that it's going to react and eat away at surfaces. Saying something is poisonous. you're explaining how it's going to react in the body. And you could also say something as easy as reacts with water. If you say lithium reacts with water, we're telling how it's going to behave in the presence of another substance. That's a chemical property. The next we're going to compare is a physical change versus a chemical change. So a chemical change results in a new substance being formed. And if you think back to a previous lesson, we said that pure substances have to be elements or compounds. So this means either a compound has bonds broken and atoms rearranged to form individual elements or smaller compounds, or individual elements rearrange and form new bonds to make new compounds. But we have to be making something new that wasn't there before. And there are 5 signs of a chemical change: color change, odor change, release of a gas, which if it's in a solution, we're going to see that as bubbles forming. The release or absorption of energy, so we're going to notice that as a temperature change. It might get hotter or it might get colder. And the last one is the formation of a precipitate. And a precipitate is when a new solid forms in the solution that wasn't there before, when we have a reaction taking place in a solution. So you mix 2 clear liquids together, and now you have a solid forming that wasn't in either of the liquids to begin with. Now, we don't want to confuse precipitate with precipitation. Precipitation is when it rains or it snows outside. A precipitate is when a solid substance forms in the solution, and because it's more dense than the liquid, it's going to slowly start settling down to the bottom. And you would see these solid particles look almost like they're raining down inside the container as they settle down to the bottom. Now, in real life, it would look more like this, where you can see there's a yellow powdery substance that's being formed, and it's going to slowly drift and settle towards the bottom as it precipitates out of the solution. Now, we have these 5 signs of a chemical change, but you don't need to have all 5 to call it a chemical change. If you see any one of these, it's a chemical change. You might have just the color changing and nothing else. Well, that's a chemical change. Or if it starts to bubble, that's a chemical change. Now, some reactions will have a combination of these, but you only need one sign visible to say that's a chemical change. Some examples of the chemical change could be rusting. We see that they have turned brown. That color change tells us there's a chemical change occurring. Digestion of food. Combustion. Combustion is just a fancy word for burning. And after you burn a log, you can see that the color has changed. While it was burning, you saw energy being released. You're going to notice an odor change as it's burning. So many signs there that it's a chemical change. By contrast now, in a physical change, the appearance is going to change, but it's still the same substance that was there at the beginning. And physical changes could be reversible, but they're not always. So for example, bending a piece of metal would be a physical change. And you can reverse that by just rebending it in the other direction. Cutting or tearing something is also a physical change. You go get your hair cut, the hair on the floor is the same as the hair that's still on your head. It's still hair. It hasn't changed to a different substance. This is not really reversible because you can't pick the hair up off the floor and reattach it to the hair that's still on your head. Dissolving anything is going to be a physical change. And here's a little picture. We see that there's a sugar cube that's going to be put into the water, and you stir it until it dissolves, and you have sugar water. You haven't made anything new. The sugar is still there. The water is still there. And you could separate the two of them back out to their original components by evaporating the water out of the container. And we also want to remember that all phase changes are physical changes, because when something melts, you haven't changed the substance. Ice is solid water. And when it melts, you have liquid water. It's still water. And when that liquid water boils, you have water vapor. It is still water. It hasn't changed to a new substance. You've just changed the phase, which means you've changed the distance between the water molecules. So now let's see how much you remember of what we just talked about. There are 8 squares here that are either describing a property or describing a change. And I'd like you to sort them out and figure out which letters would be physical properties, which letters are chemical properties, which letters are chemical change, and which letters are a physical change. Pause the video while you work, and when you're done, start the video up again. So let's check your answers. We'll start with A, mixing chocolate milk. Well, if you think about it, when you're done, you still have chocolate and you have milk. They're just mixed together. You haven't created a new substance. That's going to be a physical change. If we look at cooking eggs, that has a change in color. And so that is going to be a chemical change. And we can't reverse that. There's no way to go back and make the egg raw again. The heat from cooking it has denatured the proteins and formed new structures, and it can't be reversed. If we look at C, saying that iron can rust when exposed to oxygen, that's describing a behavior or how it's going to react. That means it's a chemical property. D says iron oxide or rust is a reddish brown solid. That's describing the color, which is going to be a physical property. E, cutting paper, is going to be a physical change. F, photosynthesis, is a chemical change because we're making new substances using carbon dioxide and water to create glucose and oxygen. Saying that liquid water has a density of 1 gram per milliliter is a physical property. We can determine the density without changing it into something new. We just need to measure its mass and volume and do a simple calculation. And then H, alkali metals usually form bases when exposed to water. That's describing how metals will react in the presence of water. That's going to be a chemical property. Thank you so much for joining me today, and I will see you soon.